Thanks for watching. If you enjoyed this video, please hit the subscribe button and ring the notification bell so you never miss an update. Leave a comment below to help grow the channel, and don't forget to smash the like button. Okay, welcome back, Lecture 4, the product and quotient rule. So last time we learned how to do basic derivatives of polynomials. We learned the polynomial rule. I think we call it the power rule. We learned how to take the derivative of a constant, and we learned some derivatives of some trig functions. Another thing we learned, though, was if we had the sum of two functions, let's say that we have f of x equals x, and g of x is equal to x squared, and we want to know what the derivative of f of x plus g of x is. Turns out it's just equal to the sum of the derivatives. So what is the derivative of f of x? It's f prime of x is just 1, and the derivative of g of x, g prime of x is just 2x. So the derivative, d over dx, of f of x plus g of x is just equal to f prime of x plus g prime of x, which is equal to, in this case, we're going to get 1 plus 2x. Now, wouldn't it be nice if the product rule was similar, right? Wouldn't it be nice if the derivative of a product was equal to the product of the derivatives? Well, is it? Let's see. Using the same example, right? I'm going to define a new function called h of x equals f of x times g of x. And that would be equal to x times x squared, or x cubed. So h prime of x, which of course is going to be the derivative of the product, would be 3x squared. What do we get if we take the product of the derivatives? Well, f prime of x times g prime of x is 1 times 2x, so just 2x. But 2x is not equal to 3x squared. Okay, so we can see that it is not the case that the derivative of a product is the product of the derivatives. So what is it then? Well, the product rule states that, first let's write that h of x equals f of x times g of x. Then h prime of x is equal to f of x times g prime of x plus g of x times f prime of x. So that's the product rule. And it's a little bit different than what you might have thought, right? Well, can we prove that this is true? Well, yes, we can. And the way that we're going to prove it is we're going to use our limit definitions for derivatives. So here is a proof of the product rule. Proof. Assuming that h of x, that the derivative, so if h prime of x exists, then we can write h prime of x as the limit as delta x approaches 0 of, not f, of h of x plus delta x minus h of x divided by delta x. That's just the definition, right? I'm going to now replace h with f and g. So this is equal to the limit as delta x approaches 0 of f of x plus delta x times g of x plus delta x. That's just substituting h of x plus delta x with the definition of h over here, minus f of x, g of x, all divided by delta x. Yes? Now the trick I'm going to do now to make this work for me is I'm going to subtract and then add. Here, let me just write it. Limit delta x approaches 0 of f of x plus delta x times g of x plus delta x minus, I'm going to subtract off an x plus delta x times g of x, but it wasn't in the original expression, so I have to add that back. F of x plus delta x times g of x, and then minus what we had down here, minus f of x times g of x divided by delta x. So what I've done is I've put in a middle term, right? I've added 0 basically in the numerator. That doesn't change anything. Why did I add? How do I add 0? Because this and this are the same, right? But they have different signs. So when you add them together, it's 0, right? But if I do that, I can now collect. You see I've got an f of x plus delta x and an f of x plus delta x here, right? So this is going to be the limit as delta x approaches 0 of, I can factor that out, f of x plus delta x times g of x plus delta x minus g of x divided by delta x. You see what I did here? I factored out this f of x plus delta x term out of these two. That left me with g of x plus delta x minus g of x. Yes? And I took the denominator part, right, and I just moved it under this one term here. But that's only part of it. I still have this other half to deal with, but here I'm going to factor out a g of x. See, because I have a g of x in both of these terms. So this is g of x times f of x plus delta x minus f of x plus delta x minus f of x over delta x. So I can move the delta x anywhere I want in these, right? You see that, yes? Yeah. And we can then use, right, remember that this, we can take some of our limit theorems, right, and write this further as the limit as delta x approaches 0 of f of x plus delta x times the limit as delta x approaches 0 of g of x plus delta x minus g of x over delta x plus, and do the same thing for this second half over here. The limit as delta x approaches 0 of f of x plus delta x is just f of x, yes? The limit as delta x approaches 0 of this, well, this is just the definition of g prime. That's the derivative of g, yes? So that's g prime of x plus, and then you get the same thing over here, right? So I'd get the limit as delta x approaches 0 of g of x is just g of x, so g of x, times, and this is the definition, the limit of this is just the definition of f prime, so f prime of x. And so there you see that we basically derived this product rule from a limit theorem, okay? Using just a little trick, we just added 0 to the numerator. Just have to be clever about what 0 you add, yes? So let's try this on the problem that we started with at the beginning, right? You recall that we had f of x equal to x and g of x equal to x squared, and we wanted to find what the derivative of f of x times g of x is, so we use the product rule. So the derivative of f of x times g of x is going to be equal to f of x times g prime of x plus g of x times f prime of x. Let's write down those derivatives here. F prime of x is 1, g prime of x is 2x. Okay. Substituting in for these values, f of x is equal to x, so we get x times g prime of x is 2x, so this will be 2x squared, plus g of x, which is x squared, times f prime of x, which is 1, just gives us x squared, and so we get 2x squared plus x squared is 3x squared. And you recall that we tried doing it before by just simply making this product out, right? So we take f of x, we do derivative of f of x is x times x squared, so that's x cubed is just 3x squared. And so you see that these are the same answers, and so our product rule works. Let me give you one to try. So go ahead and use the product rule to give me the derivative of f of x times g of x. So pause the video, work that out, and come back. Okay, so using the product rule, we need f of x, which is just x squared minus 2, times g prime of x. Well, g prime of x, we should write these down. That should be the first thing we do, is take these derivatives. That's 2x plus 1, and then f prime of x is just 2x, because the derivative of 2 is 0, right? So f of x, x squared minus 2, times g prime of x, that's 2x plus 1, plus g of x, which is x squared plus x minus 1, times f prime of x, which is 2x. And so now we have to actually multiply these things out. So we'll get x squared times 2x is going to be 2x cubed. X squared times 1 is just plus x squared. Minus 2 times 2x is going to be minus 4x. Minus 2 times 1 is minus 2. Plus 2x times x squared is 2x cubed. plus x times 2x is 2x squared, and minus 1 times 2x is minus 2x. And so now we have to collect our terms. We've got 2x cubed and 2x cubed, that's 4x cubed. We've got x squared plus 2x squared, so that's plus 3x squared. We've got minus 4x minus 2x is minus 6x, and then minus 2 here at the end. And so hopefully that is right. So let's verify it by actually multiplying f of x times g of x and then taking a derivative. So we've got x squared minus 2 times x squared plus x minus 1. And we'll call this h of x, where h of x is f of x times g of x. And so what does that equal to? Well, we've got to multiply term by term, so we'll get, that's x to the 4th plus x squared times x is x cubed minus x squared. Now we'll multiply the minus 2 times these. Minus 2x squared minus 2x minus plus 2, because minus 2 times minus 1 is plus 2. The only terms to collect are these here, so that's x to the 4th plus x cubed. Minus x squared minus 2x squared is minus 3x squared minus 2x plus 2. There we go. And h prime of x is easy, right? Because now we just use the power rule on all of these terms. And so we get h prime of x is 4x cubed plus 3x squared minus 3 times 2 is 6x minus 2. And is that what we got? Yes, it is. So term by term, these guys match up. And so you see that it is true. Now, which way is easier? I don't know. In this case, I've got one thing I have to multiply. It's a 2-term expression times a 3-term expression. Over here, I have a 2-term times a 2-term plus a 3-term times a 1-term. And so which is easier, I don't know. But let me show you where the product rule really shines. So use the product rule to take the derivative of h of x, where h of x is equal to x cubed times the sine of x. So pause the video, come back when you've got that done. Okay, so using the product rule, well, we have to break this up into two pieces. So let's call the x cubed f of x, and let's call sine of x g of x. So that means that, I'll just write over here, f of x equals x cubed, which means that f prime of x is equal to 3x squared. And then I'll let g of x be equal to the sine of x, which means that g prime of x is just equal to the cosine of x. Now, as you get better at this, you don't have to write it out in so much detail every time, but I'm going to do that for your benefit here. So now using the product rule, h prime of x is going to be equal to f of x times g prime of x plus g of x times f prime of x. And then we substitute in for the value that we've already evaluated. So f of x is x cubed, g prime of x is cosine of x, and g of x is sine of x, and f prime of x is 3x squared. So we get 3x squared times the sine of x. You could factor out an x squared. So x squared times x cosine of x plus 3 sine of x, if you wanted to. So with what you know at this point, you would not have been able to evaluate this derivative any other way. So here the product rule has served us well. That brings us to the quotient rule. Now, we would expect that because of the product rule, because the derivative of the product is not the product of the derivatives, we would expect that the quotient rule must not be that the quotient of the derivative of the quotient is the quotient of the derivatives or something like that, right? But we can check it, right? We could try a function like, say, h of x equals, let's do x cubed minus 1 over x minus 1. I chose this one because I can evaluate this directly, right? At least for the case where x is not equal to 1, because you may recognize the numerator as the difference of 2 cubes. So if I were to write this over here, this would be equal to x squared plus x minus 1 times x minus 1. That's the numerator. But we've got this x minus 1 in the denominator, so those guys cancel out. You see? And so when I take h prime of x, I'm just going to get 2x plus 1. Right? Because it's just the derivative of that. if I were to equate these two, if I call this piece up here f of x, and I call this piece down here g of x, and I take the derivatives of these individually, f prime of x would then be equal to 3x squared, and g prime of x would be just 1, right? So f prime of x divided by g prime of x would be 3x squared. But this is not equal to that. Yes? So we see, again, just like with products, taking the derivative of a quotient is not as straightforward as taking the derivative of a sum or a difference. So instead of stating the quotient rule straight out this time, I think I'll just derive it, right? Instead of stating it and proving it, I'll derive it. And then we'll write down what the rule is. So we're going to take the same approach as we did with the product rule when we tried to prove it by just simply assuming that the derivative of h exists and that h of x is equal to f of x over g of x. So h of x equals f of x over g of x. If I assume that the derivative exists, what's going to be, then that means that h prime of x would be equal to the limit, as delta x approaches 0, of h of x plus delta x minus h of x over delta x. But then I can substitute in for this. H of x plus delta x is just the limit as delta x approaches 0. This will be f of x plus delta x divided by g x plus delta x minus f of x over g of x, all divided by delta x. Yes? And so what we want to do next is we want to get a common denominator in these two terms. So you can think of it as kind of pulling that 1 over x out. So I have the limit as delta x approaches 0 of 1 over delta x times, and we'll give them a common denominator. So we'll have g of x times f of x plus delta x minus f of x times g of x plus delta x. So I just multiplied the f of x over here by the denominator from this one, and I multiply the numerator here by the denominator of the one on the right. This will all be divided by g of x times g of x plus delta x. And we're going to do and I can move this 1 over delta x inside, so it's just got times delta x. Yes? And I'm going to do a similar trick that I did before. I'm going to add 0 in the numerator in a clever way. So what are we going to get up here? Well, I'm going to subtract first g of x times f of x. So I'll get g of x, f of x plus delta x minus f of x times g of x plus f of x times g of x. So that's the 0, right? Minus f of x, g of x plus delta x, all divided by delta x times g of x plus delta x. Like before, I'm going to do some factoring. This whole thing. I'm going to factor out a g of x here because I've got it in both terms. So I'll get g of x times f of x plus delta x minus f of x over delta x minus, well, actually it would be plus, and then we could factor out an f of x out of this one. But I'm going to factor out a minus f of x. So this is going to change this to minus f of x all times, and then I'm going to be left with g of x plus delta x minus g of x, all divided by delta x. And all of this will be divided by g of x times g of x plus delta x. And you can see what we've done here, right? When we take the limits, right, it'll be the limit of g of x as delta x approaches 0, just be g of x. This will become f prime of x. This will stay just f of x, and this will become g prime of x. And then this will just become g of x times g of x, right? So what is this going to give us in the end? It's going to give us our quotient rule, which will be g of x times f prime of x minus f of x times g prime of x divided by g of x squared. Okay? So that is the quotient rule. So this time we have h of x equals f of x divided by g of x. Then h prime of x is equal to g of x times f prime of x minus f of x times g prime of x divided by g of x squared. So let's try it out on that problem that we had before. Let's try taking the derivative of x cubed minus 1 over x minus 1. How would we do it? Well, we would take g of x, right? So remember, we're going to call the numerator f of x, and we're going to call the denominator g of x. And so f prime of x will be just 3x squared, and g prime of x will just be 1. So the derivative of this, it's going to be g of x, which is x minus 1, times f prime of x, which is 3x squared, minus f of x, which is x cubed minus 1, times g prime of x, which is just 1, all divided by g of x squared. So x minus 1 squared. And so if you multiply this out, what do we get? Well, it's going to give us 3x cubed minus 3x squared minus x cubed plus 1 divided by x minus 1 squared becomes plus 1. That makes this 2x cubed. And if we do either long division or we just factor this term up here at the top, right, it's going to give us that this is going to factor as x minus 1 squared times 2x plus 1 over x minus 1 squared. You see that these terms cancel, and we're just left with 2x plus 1. Now, in my opinion, for a polynomial, it was much easier to do the original problem just by simply dividing, or factoring, and then taking the derivative, than doing it this way. It seemed like this was a lot more work, okay? But again, this really shines if you've got like trig functions, for example. So let me give you a problem involving trig functions for you to try at home. So h of x equals sine of x divided by the cosine of x. So go ahead and give that a try now. Come back when you've got it done. And this is a very nice problem because who can tell me what sine of x divided by cosine of x is in general, right? There's an identity that you may recall. Tangent of x, exactly. This is just the tangent of x. Remember, last time I told you what the derivative of the sine of x was, and I told you what the derivative of the cosine of x was, and we proved it. But I did not show you how to calculate the derivative of the tangent of x because we didn't have the quotient rule. Now we have the quotient rule, so we can do it. Okay? So just note the tangent of x is equal to the sine of x divided by the cosine of x. So this is going to be useful because this will give us it'll tell us what the derivative of the tangent of x is. Okay? So we'll use the product rule. So we'll think of our f of x as being equal to the sine of x, which means that f prime of x is going to be the cosine of x. And g of x we'll think of as the denominator here, cosine of x. G prime of x is equal to minus the sine of x, using the rules we got from the last lecture. Now, I'll warn you, don't think of this as, when you think of the derivative of the g, don't think of it as cosine of x to the minus 1 power. I do that sometimes by mistake when I tried these problems, and it's a bad idea. So some people like to just ignore the quotient rule entirely, right? So if they had a problem like, x to the 5th over x to the 4th, they just say, oh, well, this is just, same thing as x to the 5th times x to the minus 4th. Now I can apply the product rule, right? Now I don't have to worry about this quotient rule. See that? So make sure you don't try to take the derivative of cosine of x to the minus 1 power. It's just the derivative of the cosine of x, which is minus sine of x. All right, so now we use the quotient rule. So just looking at it over here, g of x, which is cosine of x, so I'm going to write h prime of x equals g of x, which is cosine of x, times f prime of x. Well, f prime of x is also cosine of x. That's cosine squared of x. Minus f of x, which is sine of x, times g prime of x, but g prime of x is minus sine of x. That changes this to plus sine squared of x, yes? All divided by g of x squared. Well, g of x is cosine of x, so it'll be divided by cosine squared of x. And there's two different ways to write this answer, maybe more, but two obvious ways to do it. One is to recognize that cosine squared of x plus sine squared of x through the fundamental trigonometric identity, right, the Pythagorean theorem, that's just equal to 1. So this is equal to 1 over the cosine squared of x, which is the same thing as the secant squared of x, because 1 over the cosine of x is the definition of the secant of x, right? I personally don't like secants and cosecants. I just like to stick with the basic three, cosine, sine, and tan. But you can write it as either 1 over the cosine of x squared or secant squared of x. But there's another way to write it. I like this way better, personally. If I divide cosine squared of x into each of these terms here, right? Cosine squared of x divided by cosine squared of x is just 1. Sine squared of x divided by cosine squared of x is just the tangent squared of x. You see? And so now we know, we now have a derivative rule. I'll write this over here. D over dx of the tangent of x is equal to 1 plus the tangent squared of x. Or the secant squared of x. Or 1 over the cosine squared of x, whichever you prefer. So that's the quotient rule. It allowed us to get a new fundamental derivative for the tangent of x. I'll put a link in the description of this video, but I have a video in my Prodigy Physics channel which talks about the derivative of the tangent using a different form of calculus that Newton had developed when he was writing his Principia. You might want to check that out. It's a geometric way of doing things. So it's a totally different way of doing calculus using geometry, which is pretty neat, I think. And so you might want to watch that video. In there, we do the derivative of the tangent of x, and we don't need any product or quotient rules. But it's just a totally different way to do it. Last thing I wanted to mention is a mnemonic for the quotient rule. If we think of, and I've got my Christmas tree, or chemistry rather, shirt on, and makes you think of Santa Claus and ho ho ho, right? So let me show you a mnemonic if you have trouble remembering the quotient rule. So here we're going to say that ho is equal to low. And by low we mean the term in the denominator, the g of x. High equals high, which means the term in the numerator, or f of x. And d equals derivative. Okay? And so the expression goes ho d high minus high d ho, all divided by ho ho. So ho d high minus high d ho divided by ho ho. So ho is the denominator, so that's g of x. The d means derivative of the high part, that's the f of x. The derivative of f, that's f prime of x. So that's g of x times f prime of x minus f of x times g prime of x, all divided by g squared. Ho ho. Use it if you like. At least it would keep you from getting the sign wrong if you didn't know how to do it otherwise. I guess that's all I wanted to say about the product and the quotient rule. We did get the bonus that we got the derivative of a new fundamental trigonometric function, the derivative of the tangent of x. Next time we will talk about the chain rule in calculus. So I'll see you then.